In this video, we're going to talk about the basic operations with complex numbers. Specifically, our objective, we want to add, subtract, multiply, and divide complex numbers. Okay, so what do we know coming into this? We know what a complex number is. It is a combination of a real number and an imaginary number. It is made up of a real part, an imaginary part, and the imaginary unit, which is the square root of -1, represented by the letter I here, or in technical fields, the letter J. So A plus BI is the standard form or the rectangular form of an imaginary number. The A is the real part, the B is the imaginary part, and the I or the J is the imaginary unit. We also know what a complex conjugate is. If we're given a complex number, the complex conjugate is the same two terms with the opposite sign between them. Okay, let's get to adding, subtracting, multiplying, and dividing. My guess is you won't find this to be too overwhelming. Okay, give myself some space here. I think I'm good. Okay, we want to add, adding and subtracting, okay? To add or to subtract two complex numbers, we're simply going to add each part, or subtract, each part separately. So let's take a look at a couple of examples. Add the complex numbers 3 plus 2j and -1 plus 7j. Well, first off, I like to write my complex numbers in parentheses. It just shows that it just kind of puts it together that this is one number and this is a second number, because these two pieces must go together. So I want to add this complex number and this complex number. Adding, let's just add the real parts. So 3 plus -1 is 2. And then we'll add the non-real parts, the second piece. 2j plus 7j is 9j, and you've just added complex numbers. Okay, add each part separately. We just did that. Okay, now let's subtract, and we're going to do the same thing. We're going to subtract each part separately. So, example 2, subtract the complex numbers -2 minus 5j and 3 minus 4j. Again, I tend to use parentheses to make sure that people realize that this is a single number. We're going to subtract 3 minus 4j. Okay, now let's just subtract the real parts and the imaginary parts. -2 minus 3 is -5. And then -5j minus -4j, well, that means -5j plus 4j to subtract a negative. So that's going to be a -1j. And of course, we don't need the 1. We can leave it, but it's conventional to not write a 1 in front. So we'll write this as -5 minus j. And there's the standard form of the difference of those two complex numbers. Okay, let's take a look now at multiplication. Addition and subtraction were pretty simple. Multiplication is a little bit more complicated, but not much. Make sure I'm straightened out here. Okay, we're going to pretend like we're multiplying binomials, which you've done in the past. We're going to multiply each part of the first complex numbers by each part of the second complex number. Again, we're thinking FOIL, pretending that these are binomials, so to speak. And we want to remember something. J squared is -1. Okay, that's going to come into play here. Okay, multiply the complex numbers -3 minus 3j and 2 minus 6j. Okay, again, I'm going to put them in parentheses. -3 minus 3j times 2 minus 6j. And now you can see this looks a lot like binomials, you know, x minus 2 times 2x minus 6, for example. So we're going to use our foiling, first, outer, inner, last. So -3 times -2 is -6. -3 times -6j is positive 18j. -3 times 2 is -6j. And -3j times -6j is positive 18j squared. Hopefully you'll notice right away that I commented about j squared up here, and here's a j squared. Well, let's continue. Let's combine our like terms. Well, these two are alike, so we can come down here and say this is -6. 18j's minus 6j's leaves me with 12j's. And then I'm just going to leave this 18j squared alone for right now. Okay, so now here I am after having combined these two like terms. Now I'm going to focus here. And remember, j squared is equal to -1. That's the definition of an imaginary number. So if j squared is -1, 18 times -1 is -18. So this becomes -6 plus 12j. Again, if j squared is -1, this is -1 times positive 18. It's minus 18. And then we can combine like terms with our numbers, -6 and -18. And we get -24 plus 12j. So when we multiply two complex numbers, we need to get a complex number as the product, a real part, the imaginary part, and the imaginary unit. And the key to this one is right here, remembering that j squared is equal to -1. Okay, division. And here's where we're going to talk about that complex conjugate that we've mentioned we mentioned earlier. In division, we want to multiply both the numerator and the denominator by the complex conjugate of the denominator. So we want to divide these two numbers. Okay, I'm going to rewrite them. 1 minus 5j over 4 divided by over 4 plus 2j. Okay, now we're going to multiply this by the number 1. But we're going to write that number 1 as the complex conjugate of the denominator. Okay, whoops, that's a j there. So again, we're multiplying by a 1. We've just given that 1 a special name, 4 minus 2j over 4 minus 2j. Okay, so now we have multiplication, and we're just going to go right back to what we did up here. We're going to do first, outer, inner, last. We're going to multiply each part of the first piece, each part of the first number, by each part of the second number. So we'll go back down to here. And let's do that. So 1 times 4 is 4. 1 times -2j is -2j. Again, I'm focusing on the numerator. -5j times 4 is -20j. And then -5j times -2j is a positive 10j squared. There's the numerator having been FOILed or multiplied. Now let's do the same thing to the denominator. And you'll note we chose the conjugate for a reason. We'll see what that reason it is, and we'll see how that works in just a moment. So 4 plus 4 is 4 times 4 is 16. 4 times -2j is -8j. Positive 2j times 4 is positive 8j. If you remember your rationalizing denominators, you realize that we have a 0 right here. That was the goal. And a positive 2j times a negative 2j is a negative 4j squared. Okay, let's do some combining of like terms. The numerator has a negative 2j and a negative 20j, which is negative 22j, plus 10j squared. We saw that above in multiplication, that we could combine these two like terms. The denominator, well, look at this. The j's here zero out. So we're left with 16 minus 4j squared. Now here's that place we want to remember. J squared is equal to negative 1. So we can apply that. So we have 4 minus 22j. If this is negative 1 times 10 is negative 10. And then we have 16, okay, minus 4j squared. Well, if j squared is negative 1, negative 4 times negative 1 is positive 4. So we have 16 plus 4. We have 16 plus 4, right? Negative 4 times negative 1 is positive 4. Okay, now we can clean some stuff up a little bit here. 4 minus 10 is negative 6. And then we have a negative 22j in the numerator. And 16 plus 4 is 20 in the denominator. Now we want to write this in standard form, so we want to split out our denominator, and then we want to simplify if as necessary. So this gives us negative 6/20 minus 22/20 j. So here's our standard or our rectangular form. Negative 6/20 is our A portion, our real portion. Here's our imaginary portion, and here is our imaginary unit. This can be simplified, of course, because 6 and 20 have a common denominator of 2. So this is negative 3/10. And 22 and 20 also have a common denominator of 2. So it's 11/10, and then there's a j right there. So we're dividing two complex numbers, and we're getting a complex number written properly in the standard form as our answer.